Okay. Where's my keynote? Here it is. All right. So today we're talking about protocols. Okay. So learning objectives for today. You guys are probably seeing like the presenter notes, aren't you? Let's see. That's weird. Let me swap the screens here. Okay, cool. Yeah, so today we're talking about protocols, the learning objectives for today. There are only 2 of them. But these are like pretty big ones. So don't think that like today's just going to be an easy day, right? Number 1, understand, you should be able to understand and explain the importance of, understand and explain what a protocol is and common scenarios for their use. And then being able to define a custom protocol and make a class or struct conform to it. Okay. So from your reading, who can tell me what a protocol is?
It's a guideline from my understanding. It's like a guideline of special functions and rules that you want to create.
Okay. Yeah. And even more than a guideline, because usually guidelines are like sort of optional, right? As these are actually going to be requirements of properties or methods that like a certain type needs to have, okay? So the definition then is a blueprint of methods, properties, and other requirements that suit a particular task or piece of functionality. The protocol can then be adopted by a class structure or enumeration to provide an actual implementation of those requirements. Any type that satisfies the requirements of a protocol is said to conform to that protocol, okay? So I realize reading that definition, at least with like your knowledge of protocols right now, probably doesn't make a lot of sense, but we'll come back to it at the end, along with looking at these objectives and see like, okay, well now that definition actually makes sense because I understand all of the words around it, okay? So if you think of like a protocol, like not programming, right? Generally like certain facilities or workplaces or whatnot have like a list of protocols, right? And those are like rules and regulations that are like part of that company, right? And so, you know, we may have certain protocols when handling data loss or when such and such happens, what do we do, right? So similarly with classes and structs, they are required sort of rules or methods or properties that that's something that conforms to a specific protocol has to have in order to like be in conformance with said protocols. Okay, so let's go ahead then and just get into this. Okay, so we're going to go ahead and let me get to that link that I sent you guys so I can go through the process of forking and cloning. Let's see. Are you guys seeing a screen with Catalina on it? Or which screen are you seeing?
Yeah, it's Catalina.
Okay.
It's Catalina. Mm-hmm.
Okay, cool. Actually, is it like the dusk Catalina with like stars in the background?
Yeah. Yes.
The rocks.
Okay, cool. Yeah, the Zoom isn't highlighting the window, so I didn't know which screen was actually being shared. But like you're not seeing Slack or anything, right? Okay.
No.
Okay, cool. All right. So let's go to the starter project that I sent you. Right here. Okay. All right, so go ahead and open up that starter project. So this is our iOS guided project starter protocols, okay? So again, the instructions are to please fork and clone this repository to prepare for the guided project, okay? So what you need to do, remember to fork a repository, you're gonna click on this little fork button in the top right, okay? So we can fork it, and then you decide, where do you want to fork this project to? Well, you want to do it to your personal account. So we can go ahead and we can fork it to our personal account. So then it will say forking, okay, and the reason that we need to fork a project is because if the project is as part of like some other organization, we're not going to be able to like pull and push, or we won't be able to like push pull requests and stuff directly to it, right? And so it's better to have it as our own project, and then we can submit pull requests if for some reason we want to make like any improvements to that person's project. But we have a lot more flexibility when it's part of our project. So let's go ahead, and now that we have that, we're going to click on the clone or download. Okay. Remember, we don't want to do the download zip because then we don't get access to like all of the get information. We want to clone it. Okay. So it says clone with HTTPS. So go ahead and copy that URL. Okay. And then we're going to open up terminal. Okay. And let's navigate to our development folder where we save everything. Okay. And then we're just going to do a get clone and then paste in that URL. Get clone and then paste in the URL. Okay, and then go ahead and press enter. So then it should say it's cloning everything over. And so now, if I look inside of that directory, so ls, where did it go? Right here. iOS Guided Project Starter Protocols. Okay, so let's go ahead and CD into that new folder or directory that we created. Oh, CD. Okay, and now we're ready to go. We don't have to do any Git configuration. The Git is already configured, so anytime we pull or push or commit or whatnot, well, once we commit and push, it's going to push directly to that repository. Okay, so that's sort of like the reverse of what we have been doing, where we create it locally first and then we push it up. Right now, it started out as a remote. We cloned it to our system, and so that connection has already been made. I'm sure you guys are already pretty familiar with that as you've been doing that with your homework and whatnot. But hopefully you're feeling pretty good about that process. Okay, so let's go ahead and open that playground up then. Give you a second to do so. Okay, let me bring it onto the screen. Okay, so again, the starter project is pretty basic. It just has some general comments in it, so that things are, so we kind of sort of section off the things that we're going to be going through. But more importantly is we also have, it's a paginated playground. So this first page is what we're going to be doing to talk about the principles of protocols and whatnot. And then we have another page. So if you click on your page navigator up here, or if you open up the left pane navigator, you can see actually like all of the files that are inside of this playground project type thing, is we have our game, right? And so here the game has a bunch of stuff, a lot of predefined code, which is not any different. We're gonna type all of this code out by ourselves on the previous screen, but this is just copying from what we're eventually gonna be typing. But it explains the rules of the game, which we'll go over, and then we're gonna create a game and we're gonna simulate the game and see how long it takes and see how that works with protocols and whatnot. Okay. Okay, everyone got the starter project? We all good? Okay, so again, we have the definition of protocols, right? So it's a blueprint of methods and properties or other requirements that perform a specific task or function, and we can make different classes, structs, and enums conform to said protocols, meaning that those are required to have those properties or methods, etc. Okay. So the way we create a protocol begins with the keyword protocol. Okay. Let's go ahead and create a protocol called fully named. Okay. Opening and closing braces. That's how you define a protocol. Okay. Keyword protocol, name of the protocol, opening and closing braces. Pretty similar to a class or a struct. It just starts with the keyword protocol instead of struct, right? Okay, so again, this is a blueprint. So we don't actually, so any properties or methods or whatnot that we define inside of our protocol are definitions only. We don't define what they actually do. We don't define any values. We just define the existence of said properties or methods. Okay, so I'm going to do var full name of type string. Okay. Okay. And we're going to make it so that this property, we're going to add a getter to this property, meaning that we can call to and get the definition of this property. Okay. Okay, so let's create a struct for a person. Okay. And we want person to adopt this protocol. Okay, does anyone remember from the reading, how do we adopt a protocol?
You do semicolon and then you put full, well, not semicolon, sorry, 2 colons and then full name afterwards.
Yeah, so a colon and then fully named, okay? So that's step 1 is adoption, okay? There are 2 steps to protocols. There's adoption, and conformance, okay? So adoption is simply just doing colon and then the name of your protocol, okay? So now we get this error, right? And it says type person does not conform to protocol fully named. Do you want to add protocol stubs? Okay, what this error is telling us is saying, hey, you're saying that person has to like abide by the concepts of this fully named protocol, but it doesn't look like you're actually conforming to it, right? You've adopted it, but you have not conformed, okay? Do you want me to add the protocol stubs necessary in order to conform? Okay, so let's go ahead and fix. Okay, so as soon as we hit fix, we see that full name is now a property on my type person. Okay.
Hey, Johnny, would you have to also bring in the get that you have on the protocol?
No, yeah, no, that's just that's a definition allowing us to have like a getter for the property full name. Okay, and so when I mean getter, so in Swift or in programming languages, we have getters and we have setters. Okay, which a getter is just the ability to read access. Okay, and then we have write access. Okay, so read access and write access. So getting and setting. Okay, so let me give you an example here. So let's go ahead and say let Johnny equal person. Okay, and then we can go ahead and I could say, okay, the full name is Johnny Hicks, right? Okay, could say, Ben, person, full name, Ben. Okay, and then I could print out, so I could print Johnny dot full name. Okay, and we run this and we see that it's Johnny Hicks. Okay. So again, remember we have step 1 is adoption, which is just adding the colon and then the name of the protocol, okay? And then conformance, step 2, is actually adding any properties or methods associated with the protocol to your type, to your newly defined type. Okay, so let's do another example here. Let's say that we have a class for a star ship. Okay, step 1, I want this to adopt the protocol. So I'm going to do fully named. Okay. So we're going to have well, we can go ahead and we can conform, right? So we can hit on the red arrow and go ahead and fix this. Okay, so we've got a property called full name, but I'm going to have some other properties associated with my Starship. We've got prefix, which is going to be of type string optional, and then we've got a name. Okay, and so the full name is going to be the combination of the prefix and the name, right? So var prefix of type string optional, var name of type string. Okay, and then because this is a class, we are going to need to add an initializer. So let's go ahead and initialize with a name, type string, prefix of type string optional, and we'll give it a default value of nil. Okay, and then we're going to set self.name equals name and self.prefix equals prefix. Okay, we're still going to have an error here. Okay, and it's saying that we have a stored property called full name, but we haven't initialized it with anything. Okay, well, I already have everything that I need for my full name, right? Because I already have a name and I already have a prefix, so I don't need to add that to the initializer. So what I'm going to do is I'm going to make full name, and I believe we've talked about this, I'm going to make full name what we call a computed property. Okay, a computed property or like a calculated property. Okay, because I already have all of the pieces I need to define the value of this property, right? Like in algebra, I already have the x and the y, okay, and I know that x plus y equals z, right? So if I have the x and the y, I'm good to just go ahead and create z. So what we're going to do is we're going to make full name a computed property, okay? And the way that we do that is we define the property's name, so var full name of type string, but then I'm going to do an opening and closing brace, okay? This right here is a closure, so everything inside of it is going to be a part of calculating or computing the value of that property, okay? So what I want to do is I want to return, and I want to run a check here. Remember I think first day we talked about tertiary operators, ternary, forgetting the keyword, ternary operators. Okay, it's this idea that we can set a value based on a given condition, okay? So in our case here, we're gonna say, let name equal, is prefix greater than or equal, or is prefix not equal to nil, okay? If we do have a prefix, then let's go ahead and we want to do prefix plus space. Otherwise, we want to do an empty string. Okay. Let name equal. Okay, plus our name. All right, so the idea behind this is our full name is either going to be our prefix with a space with the name, or it's just going to be the name, right? And so there's this idea in here of checking, let's see, this should be self.name. Okay, so we're checking, we're saying, okay, well, we want to combine string concatenation, we want to combine the prefix with the self.name if it exists, okay? If it does not exist, then we just want it to be an empty string, right? So we have a condition here that's checking, is prefix equal to nil, okay? Or is prefix not equal to nil, sorry. So if that is true, then we want to return our prefix, okay? And I'm gonna force unwrap that because I know that it's not optional. Otherwise, plus a space. Otherwise, we just want to return an empty string and then combine that with self.name, okay? And then I don't even need to define that as a new property. I can just go ahead and return that. Okay, any questions about this computed property or about ternary operators?
Hey, Johnny, can you go up real quick on the next code?
Yeah.
I think I missed something up there.
Okay.
Yeah. All right, thank you.
Cool. Okay, so we all get the full name, computer property, how it works. Okay, so calling a computer property is almost like calling a function, right? Because when I call it, when I go to read it, it's going to run a function, right? Or it's going to run a computation or a calculation and calculate what the value should be and return that, okay? So let's see it in use. So let's say I have a var ncc1701, okay? And this is going to be an instance of a Starship object, okay? Let's go ahead and initialize it with the name Enterprise and the prefix USS, okay? So if I call ncc1701.fullName, what would we expect? Okay, we're going to see that it combined the USS and the Enterprise, right? So it ran through and did that computation. Because prefix was not equal to nil, we added our prefix plus a space, and then we added our self.name. Okay, so if I do another example here, say var firefly equals starship, okay? And we'll say that my Firefly Starship doesn't have a prefix, right? So I'm not going to initialize it with a prefix because the default value is nil. We'll go ahead and call this Serenity, okay? So now if I try to read Serenity or Firefly dot full name, what's going on? Why is that not compiling? Couldn't look up symbols. Is anybody else's working, or is everyone seeing the same thing as me?
No,
Yeah,
mine's printing out
mine's
your
working.
name.
Okay. Let me restart Xcode.
Mine worked after I restarted.
Yeah, okay. Yeah, I don't know what happened. That's weird. Mine's like frozen. There we go. Okay, that was super weird. Okay, are we good with that? So defining a protocol, adopting, conforming, okay, and then we talked about computed properties, but that's not really one of the key takeaways for today. So far you should feel like pretty good about the concepts of one, creating a protocol, right, which we did up here, defining the protocol, defining any properties or methods associated with. Okay, then we have adopting the protocol, so colon, and then the protocol name. Okay, and then conformance is actually like adding the required properties or methods to your custom type. Okay, so let's create a new protocol. Okay, and we're going to do this under this new section. Protocols can also require that conforming types implement certain methods. Okay, so again, to create a protocol, we start with keyword protocol. Let's create a protocol called generates random numbers. Okay. And again, this is going to just be a blueprint, right? So we don't define how a function actually works. We just define that it has a function named such and such, right? And then that function itself is defined by the type that's actually conforming to the protocol. Okay, so this is going to have a function called random that returns an integer value. And that's it. You don't add anything more there. We're just defining that it has a function called random. Okay, and so I know that anything that conforms to generates random numbers, I know that it has at least one function. The function I know that it has is random because it has to, because that's one of the requirements of the protocol. Okay, so I know that anything that conforms to that has a function called random. Okay, I'm requiring that if anything that adopts generates random numbers. Okay, so let's say I have a class called 1 through 10. And this class conforms to generates random numbers. Okay, so we adopt by doing colon and then the name of our protocol. Okay, and then we're going to get the error that says you're not conforming. So I can go ahead and fix it. And then now this is where I define what that function actually does. Okay, but remember the definition of this function is limited to the scope of this class itself, right? I'm not defining what random does for every single type that may conform to my protocol. I do it at each level of the conforming type, okay? Because 1 through 10 can only generate a random number between 1 and 10, right? So I wouldn't want to define this as generates random number 1 through 100, right? That would maybe be part of like a separate protocol or a separate class or whatnot, right? Okay, so in here then let's go ahead and let's return int period, and then there's a method called random, okay, and then I can just define a random number between a range 1 to 10. Okay, so let's go ahead and create an instance of my class, let rand equal 1 through 10. Okay, and then I'm going to call rand.random. Run this, we see we get 8. I run it, we see we get 6, right? So it's generating a random number between 1 and 10 every single time I run the code. So here we get 10. Okay, so again, protocol definition, protocol adoption, and then protocol conformance. Okay, what questions do you guys have?
So Johnny, if we were to try and, I guess, define the function at the protocol level, would that, I guess, ruin our code when we bring it into a class?
The compiler won't let you define, it won't let you define like the actual functionality of the function, right? If I go up to here and I try to define something, turns int.random, right? Like autocomplete's not even working because like it's not gonna let you do that. Okay, protocol methods must not have bodies, okay? There is no body, only the name of the method. Okay, so you can't actually make that mistake, it won't let you. Okay, other questions? Either you guys are super confused or super smart and understand everything.
Is there a reason you would use a protocol instead of just a class and then just define like the default of everything?
Yeah, that's a good question. So it will come into play more like when we actually are building an app, and we'll see it a little bit in our game. But the idea behind it is that, let's say, for example, well, no, that's not a great example. Let's revisit your question after next class, because I think it'll make more sense like in the context of an actual application.
All right.
But yeah, but the idea behind it is it's pretty similar to to like, if you have a super class, right, generally you have to like initialize the super classes, like properties and whatnot. But protocols are a little bit more rigid, and like they are providing like a set of requirements of things that you have to implement at that level, right? Things that like, so that you can give kind of different definitions for what a method may do on each class that adopts that protocol.
Can each class only adopt one protocol or multiple?
Yeah, you can adopt unlimited protocols.
I guess that's one benefit, because you can only inherit from one class, right?
Yeah, exactly. Okay, cool. So let's talk about using built-in protocols. Okay, so there are a few protocols that Apple has provided that are just really useful protocols, because like they found that a lot of people need access to these type of things. Okay, so let's go ahead and we're going to write an extension, okay, on our Starship class. Okay, and again, an extension is just like appending to your class, right? So that I don't have to go back up to my Starship and write it inside of the original class definition. I can just write an extension or like append to my Starship class. And we're going to say that Starship also conforms to the equatable protocol. Okay, well, what is equatable? Let's open up the documentation here, Command-Shift-0. If we search for equatable, okay, so equatable is a protocol. It's a type that can be compared for value equality, okay? So remember, you know, it's pretty easy for us to look at like two strings, right? I have like string A and string B. I can look at the values of those strings and I can say they're the same or they are different, right? And that's based on the characters that make up that string, okay? But when we're defining our own types, like a person or a starship, it's not necessarily clear what makes two starships equal to one another, right? Is it, as long as they have the same prefix, are they the same? Or do they have to have the same full name, or do they just have the same name? And so we can define what it means to be equatable, or what it means when we compare two objects of the same type. How do I know whether they are equal to each other or not? Okay. So by conforming to the equatable protocol, I am saying that I need to define, let's see, Starship. I need to define how this object can be, how we can compare these objects to know if they're equal to each other, okay? So we're gonna adopt the equatable protocol, okay? I'm gonna go ahead and fix it with the protocol stubs. And then we have this really weird function, right? Which you've seen before, equals equals, okay? So that's actually a function. Whenever we do something like this, whenever we say, you know, is Johnny equal to Johnny, or if Johnny is equal to Johnny, right? And if I had property names, then print they are the same, right? So this is actually a function, okay? This equals equals is a function, and it's being defined by the equatable protocol on type string, right? The Apple has written in their code base how to define whether a string is equal to another string, right? Well, it's if they're composed of the same characters. Okay, but because Starship is our own type, we have to write what it means to be equal to each other, okay? And so we have this function here, equals equals, what does that mean? And so given two starships, left-hand side Starship versus right-hand side Starship, how do we know if they are equal to each other, okay? Well, let's say that starships are equal to each other if they share the same full name, okay? So if left-hand side dot full name is equal to right-hand side dot full name, then we'll go ahead and return true. Okay, we'll say that they are equal to each other. Otherwise, we'll say they are not equal to each other. Okay, so now that I have that, I can compare two Starship objects. So if NCC1701 is equal to Firefly, then let's go ahead and print out same Starship, and run this code, and nothing gets printed out, right? Because they are not equal to each other. They don't share the same full name, okay? And you can make this like as rigid as you want, right? So I can return if left-hand side dot full name and right-hand side dot full name are equal to each other, and left-hand side dot prefix is equal to right-hand side dot prefix, and right, like I can add all of the things that must line up for them to be equal to each other. Okay, in our case here, if they have the same full name, I know that they have the same prefix and the same name, so I'm going to say that they're equatable as long as the full name for both of them is exactly the same. Okay. Questions about equatable?
I had a question. I don't know if it's about equatable specifically, but what does static mean?
Yeah, so a static property, like when we create like a static var, is a property that is on the class itself, not an instance property. Okay, so we can have static properties and we can have instance properties, which are defined at either the class level or at like an instance level. Okay, so I could have something like this if I have, you know, person. Yeah, let's do struct person2, and we have static let species equal Homo sapien or something. That's how you spell Homo sapien. Okay, so if I created an instance of person2, so let me equal person2. Okay, that is, I can't call this on the instance level. I can't print out me dot species, okay? Because it's a property on the class itself, right? So I don't even need an instance of it because all it has is a static property. So I print out person2 dot species, okay? So it's a class level property, not an instance level property. Does that make sense, Bronson?
Yeah, thank you.
Okay, cool. All right. So next, let's talk about protocols as types. Okay. So what we may want to do is yeah, I'm going to do this whole second part together. So I'm going to give you your break first, and then we're going to get into talking about protocols of types and then jump right into the game creation stuff, okay? So let me go ahead and give you a 5-minute timer, and then we'll get back into it.
Hey, Johnny, while we're on break, can you scroll up so I could see the code I missed up top?
Yeah, how far up do you need me to go?
Go up to the first protocol. Please and thank you.
Yep.
So is private related to static then, or are they not really the same thing?
No, so private's part of like what we call access control. So a property can be when a property is private, it can only be used within the scope of the class itself. So like if I made something private, I can't access that outside of the class. Like even on an instance, if I wanted to say like, my instance dot private property would not exist because it's only accessible within the scope of like the class definition.
So you wouldn't really make something both private and static. That'd be kind of like redundant.
Yeah.
In the Starship extension, I noticed that we're using equals equals, even though that's the name of the function. Is that recursion, or is recursion something else?
No, it's not recursion because what we're really comparing down here, full name, the full name property is of type string, which the equatability of string types has already been defined by Apple, right? So full name is of type string and full name is of type string. And so because type string already conforms to equatable, I'm really just calling through to the equals equals for that type, if that makes sense. So like if I search for type string here and go down to the list of protocols that it conforms to, right, we see that it conforms to the equatable protocol. So I'm just calling the equals equals method on string itself because I'm comparing two strings.
Hey, Johnny, can you go up to Starship real quick? The first protocol, Starship. I think it was protocol. Class. Okay. Yeah, I was missing this one.
Hey, Johnny, I got that first error you did, and I had to restart Xcode. And then I got another error when we did the FNCC 1701 equals Firefly, and I had to restart Xcode again. Is that like a common thing, or is there any kind of fix?
I don't know. Some playgrounds can sometimes be iffy. I know some people have had better luck running like Mac playgrounds. It's like when you start a playground, you can choose either like iOS, I think tvOS, or Mac. All the stuff that we're doing, you can do on like a Mac playground as well. So if it's still giving you issues, maybe try a Mac playground. But yeah, playgrounds are known to be less reliable than we'd hope they would be. So
Okay. I also had there just a while back when we were doing up with a navigation controller. I was having trouble adding outlets and whatnot. So
yeah, Xcode is certainly imperfect in many ways, and that's just kind of the life of a developer, is dealing with the tools that are given to you.
for sure.
Okay, cool. So next I want to talk about protocols as types. Okay, so this is going to be kind of funky here. So when we actually create constants and variables, instead of giving them an explicit type, we can give them an explicit protocol. Okay, so it's going to look kind of weird, but I'll show you here. So let's create a class for a dice, and this is all going to feed into our game that we're going to create next. Okay, so let's say that we have a class for a dice. Okay, and a dice has a sides property. Okay, which is going to be an integer. And then it also is going to have a generator property on it, okay, which is going to be of type generates random numbers, okay. Well, that's sort of weird, right? What, like, generates random numbers is a protocol, not a type, right? Well, what we're really doing is we're saying the generator can be any type that conforms to the protocol, right? So like if you think back to when we talked about like the shapes class and like inheritance and whatnot, we said, you know, anything, like we had an array of shapes and we were able to put like a rectangle in and a circle in and then just a general shape object in them, right? And that's because they all share the same superclass. Okay, so similarly with protocols here, I'm saying that this class can have a generator that is of type anything that conforms to the generates random numbers protocol, right? Because any type that conforms to the generates random numbers is going to have a method on it that can call random, right? And roll out some random numbers or whatnot, okay? Okay, so does this make sense? So generator can literally be anything that conforms to the generates random numbers protocol. Okay, so let's go ahead and create an initializer here. We're going to initialize it with sides of type int and a generator, again, of type generates random numbers, generates random numbers. Okay, and we're going to set self.sides equals the sides that we pass in. Self.generator is equal to generator.
You got to correct your let statement up to sides as well.
Yep, thank you. Okay, and then our class is gonna have one function on it called roll. Okay, and it's gonna return an integer value. Okay, and we want it to return, it can only return a number that is like equal to the number of sides that we have, right? So if we had a 6-sided dice, it can only return numbers 1 through 6. If it's a 10-sided dice, it can return numbers 1 through 10. Okay, so we need this function to be able to be dynamic according to however many sides that we have, okay? No matter what kind of generator we may pass in, okay? So I'm gonna say return the integer value of my generator dot random, okay? Because remember, generator is gonna have a randomizer method on it, okay? But then we're gonna do modulo sides plus 1. Okay. So can you remind me what the modulo operator does?
Remainder gives you the remainder.
Gives us the remainder back, okay? So let's just think through this for a second, right? And so if I write something out and it's like confusing, we can go through it really quick and say, okay, so let's just say that the randomizer gives us, we know that, you know, it may be 0 to 10 or whatnot, right? So let's say that we have a dice. Our dice has 6 sides, okay? And let's say that the randomizer gives us 10, okay? So if we do 10 modulo 6, okay, what is that value? What is the value of 10 mod 6?
4.
4, right? So this equals 4, okay? But then plus 1, right? So 10 mod 6 plus 1 is going to be equal to 5, okay? So let's say that it gives us, you know, 10 mod sorry, let's do 1 mod. I'm not used to typing the percent sign. Like I have to like physically look at it. Okay. So if we do 1 mod 6, okay, plus 1, what is that value? What do you guys
Would it be
think?
6?
It'll just be 1.
So 1 mod 6, what's the remainder of 1 mod 6?
0.
No, the remainder.
1.
5.
Yeah, so it's 5. So plus 1 is 6. Okay. Okay, so let's say that we roll that the random generator gives us a 2. Okay. So 2 mod 6 plus 1 gives us a remainder of, right, 5. Okay, 3 mod 6.
Three.
Gives us a remainder plus 1 is 4. Okay. 4 mod 6 plus 1,
3.
3. 5 mod 6 mod 6 plus 1 is equal to 2. Okay. And then we have 6 mod 6, which is a remainder of 0. But a dice we can't roll the number 0 on a dice, right? They're not like 0 index dice, right? And so that's why we have the plus 1, is to keep us from getting any sort of 0 value, right? So plus 1 equals 1. Okay. And then obviously we could go through everything, right? And so if we get a 7 mod 6 plus 1, okay, it's equal to 2. And then 8 mod 6 plus 1 is equal to 3, and so on and so forth. Okay, so what we're doing, what this is doing, using this modulator in the number of sides, is we're sort of keeping this within the bounds of what our dice can actually be, right? So even if I passed in a generator that generated the numbers 0 to 100, right? I can only ever roll up to the number 6, right? So I have to handle that. I have to handle that to be dynamic according to how many sides my dice actually has, and and so what can I possibly roll from that? Okay, does that make sense? I realize that modulo math is like really funky, right? Like we've never like really stuff in math classes and whatnot, but usually we don't care much about the remainder. But like modulo is like, it's all about the remainder, right? Okay, cool. So knowing this, let's go ahead and let's say we've got a 6-sided dice, right? So var d6 equals dice. Okay, and let's initialize it with 6 sides, and we'll initialize it with the generator. Let's go ahead and do our 1 through 10 generator. Okay, and then let's just roll the dice 5 times just to see what we get. Okay, so we're going to say for underscore in 1 to 5, let's go ahead and print random dice roll is d6 dot roll. Okay, and I can run this. We see that we run a 3, 4, 6, 4, 5. Okay, so if you've rolled anything outside of that, that means that you didn't define your roll function correctly. Okay, anything outside of 1 and 6 means that there's something wrong with your roll method. Okay, are we ready to run into our game? Start building out the game? Questions? Okay, cool. So let's go ahead and let's navigate over to our game. Okay, so if you go to the game file, you see that we've actually extracted some of the code that we just wrote, right? So we've got our generates random numbers protocol. We've got our 1 through 10, a 1 through 10 class that conforms to generate random numbers. And then we've got our class dice. So literally everything that we just wrote, right? Because we're gonna use this as part of our game. Okay, so the game that we're building here, we're not building a game that you're actually gonna be able to run on your app and play. We're just building like a simulation of how of taking turns and whatnot and printing out like what happens. Okay, so here's the game. It's a game called Knockout. It's a dice game and it's played using the following rules. Okay, so each player chooses a knockout number, either 6, 7, 8, or 9. Okay, so only one of those 4. More than one player can choose the same number, okay? Rule number 2, players are gonna take turns rolling both their dice. So everyone has 2 dice, okay? They're gonna take turns throwing both dice once each turn, and then we're gonna add the number of both the dice to the player's running score, okay? Maybe if you guys ever played Pass the Pig or whatnot, where you roll the little pigs. So it's pretty similar that if you roll with the pigs that have both their, I don't even remember what the rules are, but if you roll a certain combination of pigs, then you are out, okay? So if a player rolls their own knockout number, they're knocked out of the game. Okay, play ends when either all the players have been knocked out or if a single player scores 100 points or higher, okay? So again, we're reusing some of the work we've already defined, right? We already have a dice class where we can initialize with size and generator and whatnot. Okay, but now we're gonna actually build out these rules of this game, okay? Okay, so let's go ahead and define a couple of protocols for managing this game, okay? So first off, we're gonna have a protocol for a dice game, okay? And any dice game needs to have some dice, okay? And then we're gonna have a function to play, to begin the play of the game. Okay, we're going to create one more protocol called dice game delegate. Okay, and the dice game delegate is going to have a couple of functions on it. Game did start. Okay, and this is going to be called when our game starts, and we're going to pass in a dice game. Okay, let's have another function, game, dice game, and we're gonna have, this is gonna report anytime we get to new turns. So we're gonna say dice game here, and then did start new turn with dice roll. Okay, type int. Okay, and then we also have a function here for game did end. Okay, and you'll see how these are going to come into play in a second. Okay, once you've got these two protocols defined, let's go ahead and have you raise your hand. Okay, and I will note, we're going to write this and you guys are going to be like, holy smokes, I didn't even follow anything that we did. Remember what the key objectives are for today, right? So I'm just giving you an example of protocols and whatnot in use. But as far as the math and the logic behind this, it's going to make your brain spin a lot and you'll be really confused. And just take time to learn it and whatnot. But remember, the actual rules of the game and creating this game is not the key objective for today. Okay. So again, this protocol here is an example of what we call a delegate, and we're going to be covering these more in detail with additional examples and whatnot in our next lesson. But just to give you an idea of what a delegate provides, a delegate, like the definition of a delegate is like a person sent or authorized to represent others, in particular, an elected representative sent to a conference, okay? So similarly, in programming, a delegate is going to be sort of like a representation of a specific class, okay? And we're gonna see it in action here. But we're gonna have kind of two pieces to our game. We're gonna have the actual like brain of the game, like the actual logic of the rules and whatnot. But then I want to have a delegate who is in charge of reporting what's actually happening in the game, okay? So if you think of like watching a football game or not even watching, but like listening to a football game or a basketball game on the radio, right? Is you have people that are there at the game, and you're not there, but you have people that are at the game and they're reporting like, hey, you know, LeBron James passed the ball to this person, blah, 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 right? And so similarly, we're going to have like our game that's actually taking place, and then we're going to have a delegate that's going to report, like actually print out information about what took place in the game. Okay, and that's what these functions are, is this dice game delegate is going to report when the game started, when the game ended, and what happened each turn of the game. Okay. Okay, but it'll make more sense probably on Wednesday. All right, so let's add some supporting types that we're going to need for our game. So every game is going to also consist of some players, okay? So let's create a class for a player object. The player is going to have an ID of type int. They're going to have a knockout number, okay? And for the purposes of our game, let's go ahead and just give them a random knockout number. So we're going to say int random. And the rules for the game define that knockout numbers are between 6 and 9. 6 and 9. Okay. A player also is going to have a score associated with them. Give that an initial value of 0. And we needed a property to know whether they've been knocked out or not. Okay. Well, it's going to be false initially, right? Because everyone's part of the game at the beginning. And so our only job is we're going to initialize with an ID. Self.id equals ID. Six dot 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 9. All right. Okay, so once you've got the two protocols and the helper class for player, let's go ahead and have you raise your Zoom hands. You guys aren't asking enough questions. We're super ahead of schedule. Guess we'll have lots of time at the end to go over anything we need to.
Hey Johnny, for the init.random, which one did you use for the parentheses? Because mine keeps coming up with an error.
For the int.random?
Oh, never mind. I see what you did. You still, because I thought I saw you put only 2 dots, but I see.
Oh, I did. I did on accident. I accidentally put 2 dots. It should be 3 dots.
Oh, okay, good to go.
Yeah.
Thank you.
Hey, Johnny, I had watched a little bit of the one of the previous ones, and they didn't have the knockout number defined there. They are basically the int random. They actually had it in a self.knockout number int.random. What's the benefit to do it in either way, or does it really matter?
Well, so like in a real world scenario, I'd want to like allow the user to define their own knockout number. And so I'd want to initialize it with whatever like the user passes in of like, oh, I want to be 7, or I want to be 8, or I want to be 9. But because we're really just running a simulation, I'm just going to give everyone a random knockout number.
Okay, fair enough.
Okay, so let's define the actual game now. Okay, so we've got all this helper stuff. Let's build a dice game. Okay, and the class is going to be called Knockout. Okay, and Knockout is of type dice game. Or not type, but is going to adopt the dice game protocol. Okay, so again, adoption, : name of the protocol. Okay, then we can hit this and we can add our protocol stubs. So any game that's a dice game needs to have dice, and then it needs to have a function on it called play. Okay. And this doesn't, I just need to have a property called dice. I haven't defined that it's like required to be a var versus a constant. So I can change this to be like let dice equal. And let's go ahead and initialize it with dice. Okay, the game is going to consist of 6-sided die using the 1 through 10 generator. Okay, we're going to have a property on here for players. Okay, and this is going to be an array of player objects. Okay, and we're going to initialize it with just an empty array. Sorry, let me make this bigger so it's a little bit easier to read. Okay, and then as part of initializing my game, I'm just going to initialize with however many players are playing. Okay, and then I'm going to generate and I'm going to populate my players array with the number of players. I'm just going to create a bunch of random players. Okay, so I'm going to say for I in 1 up to the number of players. Okay, let's go ahead and say let a player equal player, and then we'll initialize them with just the ID for the current number in the iteration, so I. Okay, and then we're going to do players dot append a player. Okay, so I'm just initially, so however many players I pass in, if I'm saying, hey, we're playing with 8 people, I'm going to go and I'm going to say, okay, well, we've got 8 players. I'm going to assign them an ID, player 1, player 2, player 3, player 4, up to player 8. Okay. Okay, so if you wanted to, what you could do is you could say player and then interpolate. Like this, right? Player 1, player 2, player 3, player 4. Oh, but I guess we defined that our ID has to be a number. So never mind. Let's just leave it at I. Okay. So play is where we're going to define the actual rules of the game. This is where like we're going to run our play simulation. Okay. So again, remember, think back to the example I talked to you about our delegate, right? And so we've got the game that's happening, we've got our announcers, and then we've got us on the radio. That the announcers are sort of like our delegate letting us know what's happening at the game. Okay. So because we can't be there, we need announcers there to tell us what's happening at the game. Okay, similarly in our program, we may have like a view controller that the view controller cannot be like part of the brain, right? It's a completely separate entity, but it can send a delegate to get information about, okay, what's happening in the game, and then I'm gonna update my layout and my photos and whatnot, or whatever I have on screen, according to what's happening in the brain, what's happening in the game, okay? So inside of our play method, well, actually, so let's go ahead and let's create a delegate, okay? And our delegate is going to be of type dice game delegate, okay? So just like you have basketball announcers, you've got people who are announcers for football games or baseball games or whatnot, right? So this is going to be a delegate of type dice game delegate, okay? And so a dice game delegate, anything that conforms to the dice game delegate knows how to like sort of announce or call or report like what's happening during that game through the methods, the game did start, game did end, and this is what happened each turn, right? So we've defined those set of rules that anything that conforms to that dice game delegate can report that kind of information, okay? So this is going to be an optional delegate property, okay? Okay. So when we call play, let's go ahead and have our delegate tell us that the game has started. Game did start with self, right? Our knockout game has started. Okay, so we're gonna have one property here, reached game end, okay, and it's gonna be equal to false, right? So when we call play, the game is not over, okay? And we're gonna continue to play as long as the game has not reached the end. Okay, so we're gonna do a while loop here. Okay, we haven't used the while loop really. So this is gonna iterate as many times as it needs to until reached game end is equal to true. Okay, so you need to make sure that whenever you use a while loop, you always are providing a way for reached game end or for whatever property you have to be equal to true. Okay, or I guess equal to false so that it falls out, right? And because you can fall into an infinite loop if reached game end never actually becomes true, then we're going to be in this while loop forever, right? Because reached game end is always going to be true. So make sure inside of your while loop, you're always providing some way for the game to end or for the loop, for a way to exit the loop. Okay, so we start the game. Each player is going to take a turn. Okay, so let's go ahead and we're going to write a for loop. We're going to say for player in our players array, but we only want the players who have not been knocked out to continue to play. Okay, so for player in players, where player.knocked out is equal to false, then what? Okay, so tell me what the rules are. Okay, so what does each player do? What are the rules of knockout?
They're rolling the dice.
Okay, so rolling the dice. Okay, then what?
Checking the number to see if it's their knockout number.
Okay, so check knockout number. Okay, if it is their knockout number, what happens?
They get knocked out.
They get knocked out, right? If they hit their knockout number, if it is knockout number, goodbye player. Okay, if it's not their knockout number, what happens?
They continue playing.
Yeah, but what do we do with their roll?
They just continue rolling, don't they? Or you add their numbers.
Yeah, because we're playing to 100. Remember, we're playing to 100, right? Because there has to be some way for the game to end. Because I mean, though unlikely, it's possible that you could roll forever, and the game would never end because you never hit your knockout number. It's very unlikely, but again, it's possible. So if they haven't rolled their knockout number, then we're going to add score to running score for that player. Okay, so how does the game end? There are two ways it can end, right?
When you get knocked out and when you reach 100 or better.
Okay, so the game is over when all players are knocked out, or when a player reaches 100. Okay, so I'm typing this in here to help you like think that like you have to think of like what are we actually trying to accomplish before you start writing the code, right? What are the rules of the game, and then we can convert all of that to code. Okay. So we're looping through each player and we want them to roll the dice. Okay. So let's go ahead and let's say that the sum of their roll, so let dice roll sum equal, and we're going to call roll twice on the dice. Okay, dice.roll plus dice.roll. Okay, so we've rolled the dice. Okay, we're also going to report, right? You know, LeBron James shoots a 3, right? We're going to report this person rolled this, right? So let's go ahead and let's let our delegate know. We're going to say delegate game self did start new turn with dice roll sum. Not zoom, dice roll sum. Let me update that here. Okay. So we've rolled. We've also let our delegate know what they rolled. Okay. Now we want to check and make sure did they get their knockout number. So if our dice roll sum is equal to what?
The knockout.
The knockout number, which is where?
6 through 9.
Right, but how do I get how do I know what the knockout number is in this iteration?
Through class knockout, right?
So we have our player object, right? So if the dice roll sum is equal to the current player's
knockout number.
Yeah. If our sum is equal to our player's knockout number for whoever player's turn it is, right? Then let's go ahead and let's print out, you know, player, and we'll pass in our player .id is knocked out by rolling player.knockout number. Okay. All right. And so let me bring this up. Okay. So we're printing out that they've been knocked out, but now we actually need to knock them out, right? So we're going to set player.knockedOut equal to true, right? Because they don't get to play anymore as soon as they've been knocked out. And remember, every time through the loop, we're checking, and we're only including the players who have not been knocked out, right? So I do need to define when a player has been knocked out. So I'm going to say player knocked out is equal to true. Okay. Okay, so after that, what we need to do is I need to check and see how many active players do I have. Okay, remember, and then this is going to be part of the else, adding the total scores here, right? So if this player gets knocked out and, you know, maybe they're the last player, then I'm going to need to end my game. Okay, so what I need to do is I need to see after this player is knocked out, how many active players do I have left? So let's go ahead and we're going to say let active players equal players dot filter. Okay, and I want to filter out all of the players that have been knocked out. So we're going to say $0, which again is just a placeholder for a current player in an iteration. Okay, knocked out is equal to false. All right, so give me all of the currently active players. Go ahead and filter those out. Okay, and you'll talk a lot more about these high level like filter type functions, filter and sort and whatnot in the next unit. Okay. Okay, so if our active players dot count is equal to 0, it means that the game is over. Okay, and we define that the game is over through our reached game end property is equal to true. Okay, and then we'll go ahead and print out all players have been knocked out. Okay, we good with this logic here? Knocking a player out.
Johnny,
Yeah.
for my 4-player and players is getting a actually that's the delegate question game did start. It's getting a error, and I just don't know why. Where I did it wrong. We can go back to it later if we need to. But
Yeah, let's come back to it. We'll finish the logic because we'll be done pretty early. We'll be done probably in the next like 10 minutes. So we'll come back to it at the end, and I can help you get it resolved. Okay. Game ends if all players are knocked out. Okay. All right. So we've handled if the player rolls their knockout number. Okay. So now let's go into our else, and we're going to calculate their running score, right? So we're going to say player dot score plus equals the dice roll sum. Okay. But again, the game ends when this player reaches 100, right? So we're going to say if the player's score now is greater than or equal to 100, then let's go ahead and call reached game end equals true. And we'll print out player dot-id has one with a final score of player dot score. Okay, so again, there's our rule there that we defined. Game ends when a player reaches 100, right? So in both cases, I've provided the ability for reached game end to be equal to true, okay? So that's an important thing to not get stuck in a while loop, is that both conditions must have some way of resolving so that your while, whatever your while property is relying on, will eventually be true. Okay, so the game either ends when everyone gets knocked out or when someone reaches 100. I'm guaranteed that one of those things is going to happen, right? We're either going to hit our knockout number or accumulate our score up to 100, and then the game ends. Okay. So as soon as the game ends here, let's go ahead and let our delegate know that our game did end. And we'll pass in self, the current game. Okay. Remember, this is all a blueprint, right? This is a blueprint of a knockout game, right? So we'd actually need to have a like an instance of knockout that we can call play on, okay? But similarly, we're going to need to pass in a delegate on that instance, our delegate or our announcers, right, that are going to give us some information about what's going on in the game, okay? So let's go ahead and, well, actually, does everybody have the rules for the game? Does anyone need me to scroll anywhere, or does everyone have the code?
Is that delegate game did end self supposed to be in the for loop or the while loop or outside of both?
It's outside of, well, yeah, it should be outside of the while loop.
Okay.
right there where it says else under all players have been knocked out. I'm getting a error right there saying it's supposed to be a do statement.
A do statement?
Yeah, it says, did you mean to use a do statement? And then if I hit fix, it just says do bracket else.
Do you have your if up here?
Yeah.
Yeah, let's take a look. I'll look at yours, and then who else was having issues that I needed to look at?
Oh, I am. I'm a little behind on the code. So
Okay. All right. Well, Michael, let's have you share your screen really quick. Just get that resolved. We'll make sure that everyone's like up to this point, and then we'll continue.
Hey, Mike, you got a curly bracket facing the wrong way on else, it looks like.
Yep. Both of them on either side of else.
Yeah.
Oh.
Yeah. So else should be, yeah, the first one should be a closing bracket, and then else should be an opening bracket. Okay, scroll up for me a little bit. Okay. So it looks like you just have an extra brace like on line 98. Go ahead and remove the brace on line 98. Okay, and I think you should be good.
Thank you.
Yep. All right, does anyone else need me to look at theirs?
I'm getting an error when I try to run mine. Saying 1 through 10 does not conform to generate random numbers. I think it's from the first section that we did.
Okay, let's take a look at it. If you want to share your screen real quick.
Yeah.
Okay, yeah, let's go back to your protocol basics. Okay.
There's down just a little bit.
Yeah, go down for me. Through 10 does not conform. Okay, so where's your 1 through 10 definition? 1 through 10. Yeah, so 1 through 10 needs to conform to your generates random numbers protocol. So you need to adopt and conform on line 48.
Oh.
Yeah. There you go.
Okay. All right. Thank you.
Yeah, that should be good now. There you go. Nice. Okay, does anyone else need me to look at what's going on their computer? Or do most of you just need to see my screen again?
yeah, I just need to see your screen.
Okay. Okay, how far up do you need me to scroll? Or are you good right here?
Let me see. Can you go up a little bit?
Yeah.
So the play function, I guess, function play. Yeah, right there. Perfect. Sorry, give me just a minute to see what I did wrong.
You're good.
All right, should be good. Thank you.
Of Okay, anyone else need anything?
Hey, Johnny, my
I just need to go back down to the bottom to where you had the else statement.
Okay, cool. What were you saying, Sammy?
oh, mine keeps on giving me an error for where you have the filter player filter. It keeps coming up as value of player has no member filter.
So players.
Players.
Yep.
Oh,
You want to filter on the array of players.
oh, I see. Okay, thank you.
Yep. Okay. Aaron Peterson, you good? Cool. Okay. All right. So last piece. Okay. Last piece. Okay, so the following class is going to be used to track the status of the above game and will conform to the dice game delegate protocol. Okay. So let's go ahead and we're going to say class dice game tracker, and we're going to adopt and conform to the dice game delegate protocol. Okay, let's go ahead and add the protocol stubs. Okay, and you'll see these are pretty familiar, right? This is where we're actually defining what happens when the game starts, what happens when the player takes a turn, what happens when the game ends, what information are we reporting, right? So again, think of like the relationship. You've got the basketball game, the arena, you've got the radio announcers, and then you've got me who's listening to the radio, right? So I'm not in the arena, but I have delegates over there who are watching the game, letting me know what's happening. And then as the delegates, they're actually going to define like, hey, like LeBron James scored a 3, like now the Lakers are up, blah, 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 right? So we've got our dice game delegate here, which is going to define what actually happens or what's reported when the brain or when in the arena, when something happens, what is actually announced or reported, okay? So game did start turn, and game did end, right? So these are all going to get called when within the brain, when game did start. So when we're calling delegate, game did start, delegate, game did start, new turn with dice roll, and delegate, game did end, we're calling those over on the delegate, right? So on here, right? So this is actually what's going to happen when we call those functions, assuming we set the delegate properly. Okay, so in my dice game tracker, let's go ahead and let's create a property for number of turns. Okay. So when the game starts, number of turns, we need to set our number of turns equal to 0. Okay. And then let's go ahead and we're going to make sure if our game is a game of knockout, then we want to print out started, right? So like a basketball announcer, they can be an announcer for a Lakers game or for a Jazz game or for a Cavs game or whatnot, right? And so we're saying, hey, we started a new game of knockout, or oh, here are the Lakers, here are the Rockets, blah, 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 right? So we're defining, we're saying if the game starts, let's go ahead, and if it's a game of knockout, let's print out, started a new game of knockout, okay? I'm sorry for all of those of you who hate basketball or don't even know what I'm talking about. And hopefully like the analogy is making more sense. I don't know. Maybe it's actually making it worse. Okay. So if the game is knockout, let's go ahead and print out that we started a new game. And let's also print out some information. The game is using a game.dice.sides sided dice. Okay, so when we start a new turn, let's go ahead and we're going to increment our number of turns plus equals 1. Okay, and then we're going to print out rolled, and then pass in our dice roll. Okay, so we're going to increment our number of turns every time that this is called, right? So every time we iterate through that loop, we're calling to the delegate and saying, hey, we're starting a new turn. But the delegate itself is what's keeping track of how many turns we're at. Okay, so we increment the number of turns, and then we're going to print out what was actually rolled. Okay, when the game ends, let's go ahead and print the game lasted for this number, however many number of turns. Okay, once you've got the dice game tracker down, let's go ahead and have you raise your hand, your Zoom hand. All right, ready to actually test our game? We've come all this way. Look at this, we're on line 134. That's a lot of code. Okay, so finally, let's test out our game. We're going to create a game instance. We're going to add a tracker and then instruct the game to play. Okay, so let's create our tracker. Dice game tracker. Okay, let's initialize a game. It's going to be knockout. And let's play it with, let's do 5 players to start. Okay, now we need to set the tracker as the delegate for the game. Okay, because the tracker is what's actually like reporting what's happening in the game. So they are the delegate for the game. Or just like announcers are watching the game, they're the delegate for the game for me to know what's going on. Okay, so we're going to say game.delegate is equal to tracker. Okay, the tracker is the game's delegate. Okay, and then last step, it's called game.play. Okay, and now we're going to run a simulation. So I'm going to run this. Okay, it ran pretty quickly. We have a bunch of stuff that printed out. Okay, so let's see what happened. So I started a new game of knockout. That was reported to me from the delegate, right? The delegate let me know that the game started. It also let me know that the game is using a 6-sided dice. Okay, so we roll a 6. The game lasted for, hold on, I'm gonna make sure this is right. Player 5 is knocked out. Maybe we're printing out too much stuff. The game lasted, let me go back here real quick. Game did end. I'm calling game did end too many times. I think I'm 1 brace 2. Oh yeah, I'm calling this inside of my loop. What was I thinking? Oop. It's in the wrong brace. Sorry guys. I'm gonna make sure that this is outside of the while loop. I'm gonna make my text smaller so I can actually see. Okay. Seriously? Okay, yeah, so outside of the while loop is when we want to call game did end. That's why we're seeing the game, the game lasted 1 turn, but then the game continued. Okay, so let me run this again. It's bigger. Okay, all right, that's much better. Okay, so we start a new game of Knockout. The game is using a 6-sided dice, okay? So we roll a 5, roll a 7, roll a 6, roll an 8. Then player 4 gets knocked out by rolling an 8. Okay, we roll a 6, 8, 10, 9, 7, 6, 4, blah, blah, blah. Player 2 gets knocked out. Okay, then we roll 8, 7, 6, 7. Player 3 is knocked out by rolling a 7. Player 5 gets knocked out by rolling an 8. And player 1 then rolls a 7. And then they're knocked out by rolling a 7. All the players were knocked out after 17 turns. Okay. So again, what we can update the information that's reported. Maybe we want to see like, well, who rolled a 6, right? And so I can go in and we see, okay, well, where are we reporting such and such rolled a 6? Okay, if we go to down here in our delegate, right? The dice game tracker. I guess we're technically not passing the player through. So what we could do, well, we can make that extra credit at the end, right? What I could do is I could pass the information, because again, remember the tracker doesn't have like direct access to the player. I need to like pass the information over to the delegate about this player rolled such and such, right? But it does appear that our game is working, right? So if I wanted to play with like 100 players and run it, maybe don't do it if you have a slow computer. Okay, so we played with 100 people. Player 96 won with a final score of 101 and the game was 548 turns were taken. Okay, but player 96, big winner right there with a 101. Well, actually, it looks like player 19 won with 106 before player 96. So they all kind of got like final turns, and it looks like 3 people actually won on this random iteration. And obviously, we could fix up our code to handle those kind of situations, but for simplicity's sake, I'm going to stop where we're at. Okay, we got 15 minutes left. I just realized we haven't committed anything, which is my bad. So let's go ahead and do that. So we're going to go to terminal here. Let's go ahead and do get add period, get commit, added logic for knockout, and then git push. Okay, so now all those changes are pushed up to our repository. Okay, so that's everything that I have for you today. So let's go back. Don't worry, I'll take your questions as soon as this. I want to make sure that anyone that feels good can leave. So let me bring up my protocol keynote again. Okay, so again, at the end of this module, we did a ton of stuff, right? But here are the learning objectives for today. Understand and explain what a protocol is and common scenarios for their use. Okay, so again, when we want to define a list of properties and methods that are required by a specific type, or if you think of this idea of being able to communicate information from like a brain object to maybe like a view controller, right? Because the view controller is not part of the brain, but we need to be able to pass information back and forth so we can pass them through like a protocol and a delegate, okay? And then the next one is defining a custom protocol and making a class or struct adopt and conform to it, okay? Conforming obviously implies adoption as well, but those are the 2 takeaways. So the game logic and whatnot was like kind of above and beyond. You should definitely go through and like make sure that it makes sense, because it applies a lot of like the principles of Swift in general, and you should know how to like think algorithmically. But again, these are like the key takeaways for today. So if you feel good about those things, Samira or Austin or Aaron, if one of you can post the homework, you guys are welcome to get started on your homework for the last, 42 minutes of class. But then I'm also happy to stay and answer any questions, go over anything I need to. I'll also send you a completed version of this if you want to use it for reference. Or actually, I'll just send you the link so that you can just clone a copy directly from my repository. So yeah, so for those of you who are going to go, we'll see you on Wednesday. Good work tonight. And then for those of you that are staying, fire away with your questions.
So I have two questions.
Sure.
The first one on line 59, will we the class knockout, and then we said that it's the dice game is the protocol. If we wanted to add multiple protocol, will we have just put like a comma and then listed the second one? Let's say.
Yeah. Yeah, so if you wanted it to be like a random number generator as well, you could do that as well. So yeah, so all of the protocols you want to adopt and conform to are just comma separated, or you can write them in a in like an extension if you want. Some people like to write them in like individual extensions so that you kind of separate out all of your conformances into different blocks.
Yeah, that sounds like it would be less confusing to look at.
Yeah.
And my second question is back on the others page, the protocol basics. I didn't quite understand the purpose of doing the when we did the what was it? The computed value.
The computed property.
Yeah, I didn't quite understand that. Like, what was the purpose? Why we had to do all that just to recut?
Yeah. So the reason that we had to do that is that full name itself is part of the fully named protocol, right? So I have to implement like a value or a definition for a full name property on the class. Okay, well, full name. So with my Starship, I have a prefix and I have a name, okay? But I need to define what is the full name, okay? Well, the full name can be computed or calculated from the prefix and the name, right? So the computed property is simply running a calculation using the two property values that I already know I have and then just combining them together.
Okay.
But I have to define a way for that value to actually like exist, right? So either through an initializer, but there's no point in initializing it because we're already initializing with the prefix and the name. So I'm just simply combining those together.
Okay.
Does that make sense?
Yeah, it does.
Cool.
All right. Well, that's all the questions I had.
Cool. Great.
I do have a question. We didn't really touch much on the get and the get set. So can you explain one more time, when do we use a get and when do we use a get set?
Yeah, so most of the time you're talking about like here.
Right, yeah.
Like when we put this get in here.
Yeah.
Yeah, so I'm trying to think of a time that I've ever actually had to do a get set. I think for simplicity, just remember with properties to the compiler is going to tell you, like, if you don't put anything, it's going to say, hey, you need like a get set. Just worry about doing get for now.
Okay, and so what is a get? It's just reading?
Yep, so every property has like a getter and a setter. Right, so if I have like a var name of type string each property in Swift really is composed of this. Okay, it has a getter and a setter. Okay, and the getter and the setter are going to be called based on of how I'm trying to access it, right? So the getter would be something like, you know, let print name, right? That would be the getter because I want to read the value, right? So it's going to run the code that's inside of this get. But again, Swift already has these defined. It already has like a getter and a setter defined. So you don't, so most properties you'll never have to like set a custom getter and setter. But like if I try to do print name, or if I try to do name equals, well, and I'd have to do this after the declaration, right? But name equals, that's going to call to the setter, right? So those are kind of already mapped and keyed to like, anytime you try to read, it's going to call the code block, right? Read stuff, set stuff, okay? But again, most of the time you don't need to like do any sort of custom getters and setters. But yeah, so with protocols though, you need to like, it just requires that you include this get in here, meaning that like you're providing a way to be able to get the value of that property.
Okay, for every variable or constant, I need to do the get. I mean, to include either get or set. Or
Only as part of a protocol. So for every property that's part of the protocol definition, yes.
Okay. And the last question is about the static. So I didn't really understand what's the static and private, and what's the difference?
Okay. Well, so private, like put private, you guys aren't going to learn about access control until unit 3, so don't worry too much about like what private is. And private and static are not related at all. Okay, so in Swift, you have what are called class properties, and then you have what are called instance properties, okay? Class properties can only be accessed on the class itself, okay? Instance properties can only be accessed via an instance of the class, okay? So there are a couple of like Swift libraries and whatnot that we have. Trying to think of like the best one. So like your phone system has, your phone has like a file system, okay? And it only has like one file system. And so generally when we're trying to call to that file system, we're not going to create a new instance of like our file system, but we want to call to like our central file system, okay? And so that would be on something like, you know, file manager dot default, right? This default is a property on the file manager class itself, right? I can't create an instance of a file manager. I can't say, you know, let file manager equal file manager and create a brand new one. If I try to do like fm dot default, it's not there, right?
Mm-hmm.
Because it's not an instance property. It's only on it can only be called on the class itself. Okay. So that's what we call a static property. This keyword static is that it's saying it's a property that can only be accessed on the class itself. Okay, so then anything that's not static is going to be an instance property, which can only be accessed via an instance of that class.
Okay, got it. Can static be on stack?
Say that again.
Can we create a static on a struct?
Oh, like you want to see what it looks like when I actually create one?
No, like an app. So we can create them on that. But like, what about structs?
Yeah, you should be able to. If I create like struct person, right? And I did this example, static let species. leave it at that. Okay. So again, this is going to be a class property, right? And this is
Oh, I see.
instance property.
Okay.
Okay. So again, if I wanted to print out species, I can call it on the class itself, right? Person dot species. Sorry, person 3. Person 3. Okay, so I call it on the class itself, not an instance of it. Okay, if I want to call out the age, then I would need to create an instance of person. Pass in their age, 28, and then print out person 3.h, something like that.
Got it. Okay. All right. Thank you.
Yeah, you're welcome. Okay, any other questions?
And Johnny, I need to,
Oh, go ahead.
I'm sorry. Going back to the protocol basics, I'm trying to find why it keeps crashing, but it keeps telling me that my Starship equitable is, there's something wrong with it. I'm not understanding why.
Okay, do you want to share your screen with me?
Yes. Oh, there we go. Are you able to see that?
Yes, it looks like you have a starship that's defined. Well, so go to where you have starship defined. Okay. Good, and then because the playground source did not compile successfully. So you've got starship, which is good.
Mm-hmm.
Use of undeclared type starship, though. Okay, that looks right. Okay, so create your instances of starship, which is good. So go ahead and run the code up to line 54. So if you hover over the gutter on line 54, just run that.
Mm-hmm.
Okay, so we know all that works. So we know it's somewhere beneath this. Okay, 1 through 10. That's not even, okay, extension on starship, we make it an equatable. Then we've got static func equals left-hand side starship, right-hand side starship. Go ahead and run it to line 77.
In the LHS dot full name, is it supposed to be a small n or a capital N? I've got capital N in mine, and it's working.
It depends on how it was defined up above.
Okay.
I don't think that's the issue. Yeah, yours should be lowercase. Okay, method must be declared public because it matches a requirement.
I had the same problem, and that was one of the things that needed Xcode to restart.
Okay.
But,
yeah, probably go ahead and restart it. I have seen a few students run into this in the past.
To go. How do you know, Johnny, if it's not your code and it's Xcode? Like, how do you tell if it's one or the other? Just restart it and hope for the best?
With playgrounds, it's always sort of a gamble. So, like, if you look at your code and you're like, I know that that's right, like, then it's, but yeah, you won't really know. I mean, there are some errors you'll see that look more like Xcode like errors, but when it's saying like your code is wrong and you know your code is right, then it's an Xcode problem.
Okay.
So yeah, let's try and run it again.
That's running. Okay. Yeah.
Let's see. Did you run the whole playground?
No, just up to 77.
Okay.
But it didn't crash that time. So
Yeah,
I think that was it.
probably good.
Let's see here.
And then age should be of type int on line 119. That should be int. There you go.
All right, good to go. Thank you, John.
Yep. Okay, anything else?
Yeah, my code only runs as many times as there are players. It says the game has lasted 5 rounds. If I make it 100 players, it says 100 rounds.
Let's take a look. Do you want to share your screen?
Yeah. Okay, so yeah, I have down here 5 players and it goes for 5 rounds.
Every single time, huh?
Yeah.
Okay. Game lasted 7 turns.
I have number of turns here, so.
Right. Yeah, your game is ending too soon, right? Like nobody, like we're not seeing that player 1, 2, 3, 4, 5, 6, or we see that player 1 is knocked out, but we don't see that anyone else is knocked out. So let's go look at your logic, your game logic.
Okay.
Okay.
Here or further up?
No, right here is good.
Okay.
All right, so we're going through each player, and they roll the dice. We call did start new turn. If the dice roll sum is equal to the player's knockout number, then we're going to print out that they were knocked out, and then set knocked out equal to true. And we're going to filter our knockout players. And if active players dot count equals 0, reached game end. Okay, yeah, so I think what's happening is I don't see your else for if they don't roll their knockout number. Where is the else for that?
Oh, right here. Are you talking about this line?
No, so that's if they do get knocked out, right? Wait, scroll up for me a little bit. Yeah. So we need an else so if it's not their knockout number, then we need to be doing something, right?
Mm.
And so all of like the player knocked out and stuff, all of that should be inside of that condition where the dice roll sum is equal to their knockout number, right? You're just printing stuff out, but you're knocking out every single player, no matter if they roll their knockout number.
Okay, I see.
Yeah.
Okay, I'll fix that later then.
Yeah. So I mean, pretty much you just need to put line 89 to 95. You just need to move that up above that brace, and then it probably will fix it.
Okay, I see.
Yeah.
All right, thank you.
Yep. All right, cool. Well, if you guys don't have anything else, I'll go ahead and shut it down, and we'll plan on seeing you all on Wednesday. Have a good night, guys.